So far we've been focusing a lot on working with multiplicative fraction problems, which are the multiplication and division. But in this next assignment, we're going to be working on classifying fraction problem types of any sort: addition, subtraction, multiplication, division, so we can really do any word problem type with fractions, right? Multiplication, division, addition, subtraction. So we're just going to do a few examples and notes on adding and subtracting fractions, which should be much less intensive than all of the stuff we've been previously doing. So here's an example. If I eat half of a pizza, and then later I eat a quarter of the pizza, how much total pizza did I eat? Well, this is an add to result unknown problem. I ate half of a pizza, and then later I ate a quarter of the pizza. How much total pizza did I eat? I know how much I ate at first, and then I know how much I ate after, and I just want to know the total amount I ate. Now, the common method is it's hard to add fractions when they are different sizes. So we commonly come up with common denominators. Right? 1/2 is equivalent to 2/4. So I ate 2/4, and then I ate 1 more fourth. So in total, I ate 3/4. Right? When you make a common denominator, all you do is add the numerators. So I could draw a picture for this, right? Pictures should make things make sense. So it says at first, I ate half of a pizza. Then later, I ate a quarter of a pizza. How much total pizza did I eat? Well, when you look at the picture, you started with the half of the pizza, and then you ate a quarter of the pizza. And I want to add those two things together to find out how much I ate, but it is hard to discuss fractions because usually a fraction has a numerator and a denominator. The numerator is the number of pieces you have. The denominator is the number of pieces that the whole was sliced up into, assuming they are equally sized pieces. And the trouble with this picture is that these pieces are not equally sized. And so the whole common denominator method says, let's make them equal sizes. So if I slice it like this, well, now my 1/2 is equivalent to 2/4. And here I ate 2/4, and then I ate another fourth. So in total, I ate 3/4. Right? The bottom does not change. Once you've made a common denominator, you simply add numerators. Now, a common issue is some people like to add the top and add the bottom. And I can go over why that is wrong in just a moment. So 2/4 plus 1/4. Some people draw a picture like this, and they say, well, I first ate 2/4, and then I ate 1/4, and so 2/4 plus 1/4, they say, well, now I have eaten 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8 pieces, right? If you add the top, you get a 3. If you add the bottom, you get an 8. So what is wrong with that is you have changed the size of the whole. These things are referring to one whole. This is referring to another. So this is a fourth of a pizza. But if I were to count it up and say that there's 8 pieces, then this would be an eighth of the 2 pizzas. And so this would say if I had 2 pizzas and I chopped them into eighths, I would have eaten 3 of those. Versus this says this is 1/4 of 1 pizza. And so the issue when you add the top and you add the bottom is you are changing your whole from 1 pizza to all of a sudden 2 pizzas. And since you are using a different size whole, you can't actually compare your fractions in that way. Which is why once we have a common denominator, we simply add the numerator so that we don't change the size of the whole that we're dealing with. All right, next question. It says, how much total liquid did my family drink today if we drank a 1/2 gallon of water and 1/6 gallon of juice? So we got a 1/2 gallon of water, and then we also drank a 1/6 gallon of juice. So how much total liquid would we drink today? This is 1/2 plus 1/6 equals what? Now this is a put together total unknown, right? The number of water is not changing. The amount of juice is not changing. It's simply we have so much water, so much juice. What do we get when we put the two things together? Now, what I could see here is that 1/2 is equal to 3/6. And so I had 3/6 of a gallon plus 1/6 of a gallon. I can have 1, 2, 3, 4 things, each of which is a sixth of a gallon. So we have 4/6 of a gallon. And then we could also write that as equivalent fraction of 2/3 of a gallon is how much liquid my family drank today. Here's another one. It says, how much further did Felicia walk than Claudia if Felicia walked 2.5 miles and Claudia walked 1 2/3 miles? So this could be Felicia. This could be Claudia. It says Claudia walked to here. Felicia walked to here. And I want to know how much further from one to the other. This is a compare problem where the difference between them is unknown. It is a compare difference unknown. Or if you would rather use a strip diagram, it says Claudia walked this far. Felicia walked this far. How much further did Felicia walk than Claudia? So let's start by drawing some nice pictures. We could do this on a number line just to mix it up. All right, so let's go 1, 1, 2, 2, 3, 3. So Felicia walked 2.5 miles. Claudia walked 1 2/3 miles. So 2.5, 1 2/3. Now again, halves and thirds are not going to line up, but an equivalent fraction for halves and thirds is sixths. And so this again is a compare difference unknown. So I'm going to say I want 2.5 miles, and then I want to take away 1 2/3 miles to see what is the difference between them. Another number sentence could say the 1 2/3 plus what gets me up to 2.5. But then to solve this, you would turn it into the corresponding subtraction sentence. Now, 2.5, that would be 5/2. Take away 5/3, right? And we could clearly see this. If we chop the top into halves and the bottom into thirds, we could say there's 1, 2, 3, 4, 5/2, or 1, 2, 3, 4, 5/3. But those are different size fractions, so let's make them equivalent sized fractions by coming up with common denominators. So this is 15/6 minus 10/6. And I could easily turn these into 6 by cutting each half into 3 pieces. And then we can hopefully see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15/6. Now if I cut each third in half, now all of a sudden these should be sixths, and I could see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixths. And so if I were to say, well, how much further is one than the other? 6, 7, 8, 9, 10. Well, I can see that this is 1, 2, 3, 4, 5 sixths difference. All right, once you make a common denominator, again, you simply subtract numerators, and we are left with 5/6 miles is how much further Felicia walked than Claudia in this example. So once we take word problems and classify them and turn them into number sentences, we can then, again, solve them from there. So just a few practices. If you wanted to add something with thirds and fourths, the common denominator would be twelfths. So you turn them into equivalent fractions, which would be 3/12 and 8/12, and then we could add and get 11/12. Or if we wanted to subtract 1 2/3, that's 5/3. Take away 3/4. Common denominator again would be 12, so this is 20/12 minus 9/12 should again be 11/12. And hopefully I didn't make any silly arithmetic errors. So in the next assignment, what you guys are going to be doing is you're going to read a word problem involving fractions, classify the word problem, type, and then model with a number sentence. We're not going to be solving them right now. Right? Once you have a word problem set up correctly, solving it should be the second step. So read and reread the word problems carefully. Think, does it have an additive structure or a multiplicative structure? Right? Additive problem types were addition, subtraction. Multiplicative were multiplication or division. And so far with the multiplication, division, fraction problems, we've only done equal groups problems. However, you could do area problems, like something is 2.5 inches this way and 3 1/3 inches this way. What is the total area? We could do area problems, we just haven't. So I'm going to limit the multiplicative ones to these things. And then you have to remember the additive problem types. There's the add to problems where you've got one quantity that gets bigger, and then you either don't know what you started with, what you changed with, or what you ended with. Or you've got the separate problems, which you have one quantity which gets smaller, and you either don't know what you started with, what you changed by, or what you ended with. And then you've got the put together problems or the compare problems, and these involve two quantities that don't change. You either have two quantities like red marbles and green marbles and the total. So this would be a put together total unknown. So this would say you know the red and green marbles, but you don't know the total. This would say the add end is unknown, so you know the red marbles and the total marbles, but not the blue marbles. Or the compare problems is two quantities and their difference. So the number of red marbles, the number of green marbles, and the difference between them. And you either don't know the difference, you either don't know the bigger quantity or the smaller quantity. So again, something to review if you haven't done these additive ones for a while. So read a word problem, decide on the problem type, model it with a number sentence, and then reread, and please ask yourself, does this make sense in this context? Because if it doesn't, then you want to reread again and think about what you're doing. That's it.